In this video, we are going to introduce the idea of a parabola, but in conics. So there's definitely more to it. Things are going to look a little bit different. We can have a vertical parabola, we can have sideways parabolas. So it's definitely going to look a little bit different. So let's talk through some of the pieces. The biggest thing is the math behind this shape of this is that your parabola has this focal point. It has a vertex just like you're familiar with. But the thing is that this focal point is a reflective property. So if you have a parabola and you have a focal point and something comes in and hits the parabola, it perfectly reflects to the focal point. So if you watch the other video, it talked about a satellite dish is kind of a three-dimensional parabola, and the signal from the dish, signal from the satellite hits the dish and focuses and intensifies your signal to a point where you can actually get a signal. So, but the way that this thing gets drawn is this directrix and the focal point. So this point right here on your parabola is exactly the same distance to the directrix, so it's at a distance of 2, that it is to the focal point, which is a distance of 2. So that's true about all the points. So if you had another point here, whatever that distance is, whatever that distance is, should be exactly the same. So if you plot all those points, a distance up and a distance out, they're going to match and basically create this graph. You're going to have an axis of symmetry. You're going to end up drawing the directrix every single time. So here's a couple options, a couple things that we got going on. So your look is going to be different than what you're familiar with your parabola. So you have two different scenarios, and you have whether your graph goes up and down or whether it goes left and right is dependent upon which variable is squared. So if x is squared, then your graph is going to go up and down. If y is squared, then your graph is going to go left and right. So it's very dependent upon two. So this one's going to be up and down, and then this is going to be left and right. Your p-value here, that 4 and the p plays a very important role. So you're going to have to kind of factor off a 4 and figure out what the p is. The p is the distance from the vertex to the directrix. And really it's going to be, the main thing is the distance from the distance from the vertex to the focus. So whatever our p-value is, it's going to look like this. So we have a parabola, we have our focal point, and whatever that distance is going to be p. Well, it's also the same distance to the directrix. So, so it's going to be in the opposite direction. So if p is 5, you go up 5, and then you go down 5 from the vertex to find it. All right, and then so this is going to be the directrix. And then if you have a sideways parabola, it's going to be similar. P is also going to be the distance, and it's going to be the distance vertex to the focus. But the difference is this shape that you got going on. You're going to have a sideways parabola, and if that value is p, then it's the other direction is where your distance away from the directrix is going to be. So that value would be negative p. Okay, and we'll talk about more of that as we get to graphing everything. So I know that there's formulas for figuring these things out, but I basically start to, once you have pieces of it, you can kind of build all of your information just from kind of knowing what all the pieces do. All right, so here are your situations. So if you have x squared, that means it's going to be left and right, but your p-value is positive, that means you're going to have this shape to it. If it is negative, your p-value is less than 0, you're going to have that value, that shape to it. And this distance, and I'll just do it on this first one, of here, that is your focal point, and that distance is going to be p. And then there's another math thing about this. Well, let me do that. And then your distance to the directrix is negative p. So you're going to have this horizontal line. That's the directrix. And then that is just going to be an equation. So it's going to be a horizontal line of y equals negative p. Now this is just assuming if it comes from the origin, which is not always going to be the case. So that's going to be tweaked. Okay, so it's not perfectly just that value. And then your focal point, at least on this, would be 0p. But again, that's not always going to be the case. It's very dependent upon where your vertex is. Now, one of the interesting things about this is this distance from here horizontal out to a point in either direction is going to be 2p. So whatever that distance up was, so if that distance is 3, this distance will be 6, and this distance will be 6. So both of those two distances will be 2p. All right. You also have an axis of symmetry, which cuts right down the middle of this thing. So at least in this situation, our axis of symmetry is going to be x equals 0. Now again, that's not always going to be the case, but it is going to be at least in this one. And then all these pieces would be flipped because your directrix, or your focal point would be here, your directrix would be here, and then you still have a line of symmetry. So if it is y squared and your p is positive, that means your parabola is going to the right. If your p value is negative, then your parabola is going to the left. All right, so now your focal point is going to be here, so p0. Again, that point's not going to be perfectly like that, but it's going to be this distance of p. And then in this direction here is where your directrix is going to be. And so that one, rather than it being a horizontal line, it's going to be a vertical line. So this is your directrix. And it's going to be an x equals, at least on this one, a negative p, because you'd go in the other direction. So it's going to be an x equals as opposed to a y equals. And then same thing here, of this distance is going to be twice whatever the p value was. So this distance in either direction is going to be 2p to kind of get you another point on your parabola. See how wide it is? And then you'd have an axis of symmetry, which is cutting through the whole thing. So your axis of symmetry is now going to be a y equals, because it's horizontal. So yeah, I don't have to memorize all of this. The biggest thing is I just have to know the direction that these things are going. So if this is a y squared and the p-value is positive, it's opening to the right, the positive direction, as opposed to the p-value being negative, then it's opening in the negative direction. And your focal point would be here, and your directrix would be here. Okay, so we'll definitely do more problems with this and kind of see all the different situations and mess with it. You're going to have to do completing the square to get things ready to go, to put these into the proper format in order to get all your pieces out in order to graph them. But once you have parabolas, the rest of the types of graphs, your ellipses, your circles, and your hyperbolas are all really similar process. They clearly look different, but the way of getting them ready to graph is very similar to what we do on this one. So that was parabolas, and then we'll start doing some examples of it next.